So, the universe's expiration date. It sounds pretty dramatic, right? Well, for decades, the story we've been told is that the universe is just going to keep expanding forever into a cold, dark, and kind of boring future. But what if that whole story is wrong? A series of really perplexing new measurements are coming in, and they're not just challenging the story, they're pointing to a much more dramatic and maybe a much sooner finale. Today, we're going to look at the evidence that suggests the universe might actually have an expiration date.
So let's just start with this question. What if the Big Bang was a round trip? I mean, we all think of it as a one-way street, right? A single explosion, and everything's been expanding outwards ever since. But what if it's more like a giant cosmic rubber band? You stretch it and stretch it and stretch it, but eventually it's going to snap back. As crazy as that sounds, new data is making that idea seem less like science fiction and more like a very real possibility.
The whole story really starts with this fundamental conflict happening in cosmology right now. Scientists call it the Hubble Crisis. The best way to think about it is like this. Imagine you're trying to measure a room with two different tape measures, but they're giving you two completely different answers. And this isn't just a tiny disagreement. We're talking about a deep, fundamental crack in the foundation of how we understand the entire cosmos.
So here are our two rulers. On one side, we have our early universe ruler. This is where scientists look at the baby picture of the universe, that faint afterglow from the Big Bang called the cosmic microwave background. Based on that, they can calculate how fast the universe should be expanding today. Then, on the other side, you've got the local universe ruler. This one is more direct. It just looks at things nearby, like pulsating stars and exploding supernovae, to measure how fast things are actually expanding right now. And here's the whole point. These two measurements do not match.
Okay, let's look at the actual numbers on this cosmic scoreboard. The early universe team, using data from the Planck satellite, gets a value for the Hubble constant of about 67 kilometers per second per megaparsec. Okay, 67. But the local universe team, SHOES, consistently gets a number closer to 73. And it's not a fluke. Other new methods, like using pulsar timing, are also pointing to that higher value. That gap, that tiny little difference between 67 and 73, is the entire crisis in a nutshell.
Now, you might be thinking, okay, so can't they just split the difference? Call it 70 and we're good? Well, in physics, it's not that simple. See, this discrepancy has become so statistically significant that it's graduated from a tension to a full-blown crisis. And that's because it has officially crossed a critical scientific threshold. The certainty that this gap is real has now crossed 5 sigma. And that's not just a number. In science, that's a declaration. It means the odds of this whole thing being a random fluke are incredibly, astronomically small.
So, what does 5 sigma actually mean? Well, in particle physics, it's literally the gold standard for claiming a new discovery. It means there is only a 1 in 3.5 million chance that what you're seeing is just a statistical accident. To put it another way, you are far more likely to get struck by lightning multiple times in your life than for this result to be a mistake. It's that certain.
This quote from the scientific community really sums it all up. The gap is too large to be a rounding error. It's statistically impossible for this to be a mistake. Basically, scientists are being forced to admit that this isn't some simple measurement error. Something is fundamentally wrong with our standard model of the universe. One of our methods, or maybe our entire understanding of how this all works, is broken.
So if our model is broken, we need a suspect. And the prime suspect has always been dark energy, that mysterious, invisible force that's supposed to be pushing the universe apart and accelerating its expansion. While some really recent data suggests dark energy's alibi is falling apart, it's not doing what we thought it was.
These massive surveys, DESI and DESI, had a breakthrough in 2025. They found compelling evidence that dark energy's density is actually declining over time. This is a huge deal because it means it's not a constant force. Our entire standard model is built on the idea that dark energy is constant. It's the lambda in Lambda-CDM. If lambda is not a constant, if it's changing, then the entire model isn't just flawed, it's broken.
And this leads us down a pretty simple but kind of terrifying chain of logic. 1. We observe that dark energy, the push that forces the universe apart, is getting weaker. 2. This implies that gravity, the pull, is eventually going to win this cosmic tug-of-war. 3. So what's the conclusion? The universe's expansion won't last forever. It's going to slow down, come to a stop, and then reverse.
And if the expansion is going to reverse, that leads to the one inescapable question: when? For the first time, scientists are actually putting a number on it. The universe, it seems, has a timeline, and it doesn't end with a whimper, it ends with a crunch.
Building on this idea of a sputtering or weakening dark energy, a team of physicists, including Henry Tye at Cornell, actually did the math. They calculated a potential new timeline for the entire life and death of our cosmos.
And here is that new timeline. We start with the Big Bang at year 0. We are right here at the 13.8 billion year mark. But look at what's next. This model suggests we're already approaching a cosmic midpoint. According to these calculations, around the 25 billion year mark, the universe could stop expanding and begin to snap back. The grand finale would be a big crunch at roughly 33 billion years.
So our understanding of the end of the universe is being completely rewritten. But what about the beginning? Well, it turns out there's another major anomaly, a huge clue from the dawn of time that suggests our story of the beginning might be just as wrong.
The James Webb Space Telescope has been peering back to the cosmic dawn, and it's finding objects that completely challenge our theories of how quickly massive structures can form. A key example is this object known as Able 2744 QSO1, and its properties are, well, they're truly puzzling.
Let's just look at the stats on this thing, because they're staggering. It's a supermassive black hole with the mass of 50 million suns. Okay, that's big. But it exists just 750 million years after the Big Bang. That's way too big, way too early. And here's the real kicker. It's naked, which means it has almost no galaxy around it. You see, the established theory is that galaxies form first and then they slowly grow a supermassive black hole at their center over billions of years. A naked black hole like this one flips that script completely. It suggests that somehow these massive black holes formed first and then acted like giant gravitational seeds that the first galaxies began to form around.
So the Hubble Crisis suggests our timeline for the universe's end is wrong. These impossible objects like QSO suggest our model for the universe's beginning is wrong. We're left with a profound question that redefines, well, everything. What if the Big Bang wasn't just the beginning of matter, but was seeded by black holes from a universe that came before?